So the first thing we're going to look at is case 1. So for the example for case 1 is greater than or equal to. So anytime we have a greater than or greater than equal to inequality with absolute value, it is going to give us and or inequality. So how that works is we end up with absolute value of x is greater than or equal to 5. And so we split that into two pieces. We're going to do x is greater than or equal to 5, or x is, we take and flip the inequality, so make it less than and equal to, and then we change the sign, so from positive to negative. So we have x is greater than or equal to 5, or x is less than or equal to negative 5. And then when I graph an inequality, this particular one, since it's less than or equal to or greater than or equal to, do I use open or closed dots? Closed. So we're going to put one at negative 5 and at 5. Whenever I graph an or inequality, does the ends of my graph go together or do the ends go apart? Apart. So that is what our graph should look like. And looking at this graph is actually kind of helps us figure out why we have to flip this sign here. So whenever we're talking about the absolute value, right, we're talking about the distance from 0. So if I look anywhere in this range that we don't have anything, what is the absolute value of negative 4? Is 4 greater than 5? No. Okay, so we have to be in a number that's further from 0 than 5. So that includes way out here and out here. So how would I do my interval notation for this? Or we do parentheses for, and since it's on the left, it would be negative infinity. Then we go to negative 5, and for negative 5, we use a bracket. How do I connect a or inequality? And then we're going to go from 5 to infinity. And infinity always gets a parentheses. So with these, just like our others, whenever we have open circles, that is where we have strictly less than, strictly greater than, and we use parentheses. Infinity also always goes with parentheses. If we have our closed dots, that is when we have less than, greater than, or equal to. And that is when we use brackets. If that helps you remember it. Remember your little animals. Now, for case 2, this is where we look at less than or equal to. So if that is going to give us an and inequality. So our example here is absolute value of x is less than or equal to 8. So for this, we'll have that x is less than or equal to 8. And x is, we take and flip our inequality, so greater than or equal to negative 8. Or we could also write that as negative 8 is less than or equal to x, which is less than or equal to 8. We can set it up either of those ways, okay? Whichever way is the easiest for you is perfectly fine. Both have their pros and cons. This way is the way all of our previous and inequalities are set up, so it's like consistency with solving. This way lets you go through the same process as you do for your ors with these, where you leave this part the same as we have, and then you take and you change the inequality, and then you change the sign. So you keep it, then switch, switch, switch. Like that lets you have consistency that way. Either way works. They both have pros. Whichever way works in your brain, I'm good with. So to graph these, we'll use open or closed dots. Closed. So we're going to have one at negative 8 and one at positive 8. It is an and inequality. So does that mean it goes together or apart? Together. And for that interval notation, I'll do negative 8 to 8. Will they get parentheses or brackets? Brackets. So we're going to look at this next little part right here. And we're going to look specifically at this first section. So it says, what does this mean? Okay, in the first blank, we're going to put that absolute value inequalities are really compound inequalities. So absolute value inequalities compound inequalities. Then we're going to do which one goes where. Okay, so if we have less than, so less than or less than equal to, okay? So we're talking, an example of that would be if we have the absolute value of x is less than or equal to 5, okay? So whenever we have less than, that is going to give us an and inequality. And when we have an and inequality, okay, we will have x is greater than or equal to 5 and, oops, not greater than, less than or equal to 5, and x is greater than or equal to negative 5. Or you could also write it as negative 5 is less than or equal to x is less than or equal to 5. Okay, that is what that's telling you. Either of those setups work. And then we also have greater than. So if we have greater than, that's us looking at like the absolute value of x is greater than or equal to 2. Whenever we have any greater than, that gives us an or inequality. When we have that or inequality, it's going to let us have x is greater than or equal to 2, or x is less than or equal to negative 2. So when we go to solve any of the absolute value inequalities, okay, step 1 is still to isolate the absolute value expression. So that is completely the same as it is when we solve absolute value inequality or equations. Exactly the same. Okay, step 2. That is where we create two cases. So we're going to either do the and or the or, okay? And it does say there's something called the KISS method to help you remember that, okay? It's where you keep the first one the exact same as you start with, okay? So you keep it, then you switch the inequality, switch the sign. So keep it, switch, switch, and that works for both. It just depends on if it's going to be and or if it's going to be or. You have to remember that less than gives you an and, greater than gives you an or, okay? But you will always keep everything the same, switch the inequality, switch the sign. Then you just solve both of your inequalities, and then you will graph and write your solutions in interval notation, okay? So the only step that is different or new is 2, okay? That's the only one that's different. That's one thing I like about doing these at the end of Unit 1 is because all of the skills we have, all we have to do is add in that one piece. So if we look at number 1, so we have the absolute value of x is less than 7. So less than gives us what kind of inequality? It's going to give us an and. So we're going to do x is less than 7, and then we're going to, we already kept the first part, so we're going to switch the inequality and switch the sign. So x is less than 7 and x is greater than negative 7. Will I use open or closed circles for those? So at negative 7, open circle, positive 7, open circle. And it's and, so it goes Yep, they'll go together. And then we just do our interval notation. So for open circles, do I use parentheses or brackets?
Parentheses.
So what do I need to put first? Then 7. And we're good. Then we're going to look at number 2. So number 2 gives us absolute value of x is greater than or equal to 4. So we have greater than. So automatically that tells us we're looking at or inequalities. So we keep for the first one, or then we swap our inequality and swap our sign. So x is greater than or equal to 4, or x is less than or equal to negative 4. And then will I use open or closed circles for this one? So we'll have a closed circle at negative 4 and an closed circle at 4. Will that go together or apart? So that is our graph. Now, to show this in interval notation, how would I show that? Mm-hmm. 4 to infinity. There we go. Perfect. Then we're going to look at 3. So here we have absolute value of x minus 1 is greater than 6. So is that an and or an or?
Or.
It is an or. Okay. So we will do x minus 1 is greater than 6, or x minus 1 is... So we keep this side the same, switch the inequality, switch the sign. And now how would I solve those? What is 6 plus 1? So x is greater than 7. Or, what is negative 6 plus 1? Hmm?
Wait,
Negative 5.
Negative 5. Because it's adding 1. Okay. So, on this one, we will graph it. Will I use open or closed circles? Open. At negative 5, we will have an open circle. And at 7, we'll have an open circle. Do they go together or apart? And that is what our graph should look like. So we will write our answer here in interval notation. So negative infinity to. Both of those will get u. Then 7 to infinity. So on today's assignment, we're actually going to do a delta math. Okay. For these on the delta math, you can answer either in interval notation or you can use inequality notation. Either way works for the answer on delta math. But before we do that, we're going to do a couple more of these together. I want us to drop down to question 6. So question 6, I had a little bit of a typo. And we're going to change that minus sign to a plus. Or that equal sign into a plus. And then after that, I had to isolate my absolute value. So what do I need to do to isolate it? Minus 1. So we get absolute value of x plus 3 is less than, what is 5 minus 1? 4. Okay, so that is a less than inequality. So is that and or or? It is and. So we will get x plus 3 is less than 4, and x plus 3 is greater than negative 4. You could also choose to set it up slightly differently by setting it up as negative 4 is less than x plus 3 is less than 4. Either setup works. I'm happy with you do either way. Okay, what do I need to do to solve these? Minus 3, so we would subtract 3. So what is 4 minus 3? So we have x is less than 1, and what is negative 4 minus 3? And x is greater than negative 7. So if you chose to do it the other way, you would still do it, but you have to make sure that you do it on both sides, and you would get negative 7 is less than x is less than 1. So at negative 7, when I use an open or closed circle? Open. At 1, when I use open or closed? And does it go together or apart?
Together.
And what would my interval notation be? All right. Will that one ever go to, will an and ever go to infinity? Mm-mm. An and will stop between 2 points, always. Okay. Now let's look at 7. So number 7 is a tricky one, okay? How do I undo that divided by negative 2? Multiply both sides by negative 2. Now, this is what makes it weird. Remember, what do you do if you multiply or divide by a negative number? So we get absolute value of 4x minus 8 is greater than or equal to, what is negative 6 times negative 2? That inequality has to flip because we multiply or divide by a negative number. Okay, that will always happen with inequalities. If you multiply or divide by a negative, the inequality flips. So we're actually looking at an and or an or inequality here. An or. So we will do 4x minus 8 is greater than or equal to 12. Or 4x minus 8 is less than or equal to negative 12. So I want y'all to go ahead and solve both of those and graph it and do the interval notation for me.
Why did you say these switch it to a word?
Because whenever we divide or multiply by a negative number, it causes your inequality, the whole inequality, to flip sides. Does anybody have any questions that you need me to help with on that? All right, so I'm putting it up here. We should have x is greater than or equal to 5 or x is less than or equal to negative 1, which our graph for that will have closed points. It will go together. And our interval notation will be bracket, negative 5 to 1 bracket. Wait. I flipped that here, and so that should be negative 1 to 5. Everything else was right, though. Wait. What did I do? I made it an and. My goodness gracious. How do I actually do this? Someone tell me. Or how would I make my graph? What do I need to change about my graph? They need to graph apart. Okay, then how would I do the interval notation for that? There we go. So we have to be careful to make sure our words and our inequalities match our graph. That was super easy for me to make that mistake. It means it's super easy for y'all to make that mistake, okay? We have to watch to make sure we're doing what we have to do for the problem, okay? We're going to skip this one, and we're going to look at the last question. Okay, so for the last question, to be able to solve this, I have to isolate my absolute value. So in order to isolate that absolute value, what do I need to do first?
Subtract 11.
Subtract 11. So we get 1/2 times the absolute value of 4x minus 4 is less than or equal to 15 minus 11, which is 4. Can I ever distribute into an absolute value? No. Okay, so we have to get rid of that fraction. How do I get rid of that fraction? I can divide it, which if you divide by a fraction, you end up multiplying by the... So here we have 2/1. So we get absolute value of 4x minus 4 is equal to 4 times 2 is... Does the divided by 1 change anything?
No.
So just bring that out. Now, that is a less than inequality. So is that an and or an or? It is an and. So we will do 4x minus 4 is less than or equal to 8. And 4x minus 4 is greater than or equal to -8. And if you choose to set it up the other way, which is fine, that would be -8 is less than or equal to 4x minus 4 less than or equal to 8. And so I want y'all to solve both of those and graph them for me. What should your answer be for this one? So from -1, okay, we have x is less than or equal to 3 and x is greater than or equal to -1, or you can say -1 is less than or equal to x is less than or equal to 3. And if I did it on a graph, both of those would have closed or open dots. Would it go together or apart?
Together.
And then our interval notation would be bracket, -1, 2, 3, bracket. All right, so I want y'all to finish question 4 and 5 for me real quick. And once you finish those, you can check your answer up here on the board. And then you are going to go ahead and get your computer out and you can start working on today's Delta Math. Delta Math has 6 questions in total. 6 of them are absolute value equations questions, and 6 of them are absolute value inequality questions. Then tomorrow and Wednesday we are going to review. Thursday and Friday is our test. Okay?